Draw a structure of Z3-methyl-2-octene. Octene means that I have 8 carbons in a chain, so I'm going to start by drawing an 8-carbon chain. 1, 2, 3, 4, 5, 6, 7, 8, 6, 7, 8. 2-ene means that I have a double bond starting from carbon 2. So my double bond must be between 2 and 3. 3-methyl means I have a methyl group, which is a CH3 group coming off of carbon 3. This is my methyl group. And the last thing I have to look at is I have to check whether my double bond is Z or E. The way I will do it is I will break my double bond into 2 halves, and I will look at each half separately, forgetting the other half. So let's say that I'm looking just at the, let's go ahead and maybe even put a note here so I don't look here. So let's say that I'm looking just at the left side. On the left side, I ask, what 2 groups is the carbon attached to double bond attached to? So I can see that this carbon that's attached to the double bond is attached to a methyl on this side, and that's it. Now, if you see only 3 bonds, that means the 4th bond is a hydrogen that was not shown. So I'm going to show a hydrogen here, and now I can compare. To compare, I go atom by atom. So there is a hydrogen, and this is a carbon. Then I ask myself, who is bigger according to the periodic table? Carbon is bigger or has a greater atomic number, and I'm going to circle the bigger one. You have to go atom by atom until you find a difference, and once you find a difference, you can circle the biggest group. Now I'm going to go ahead and forget this. Actually, let me just delete it. I'm going to forget the left side, and now I'm going to focus on the right side. On the right side, I look at the carbon that's attached to the double bond, and I ask, what 2 groups is it attached to? And I go atom by atom. So it is attached to carbon, carbon, no difference. This carbon is attached to another carbon, but this carbon is not. That's a difference. This one is bigger, so I'm going to circle it. Next, what I do is I put a line through the double bond. Let's just erase my dashed line. I put a line through the double bond, and I ask, are the 2 groups that are circled on the same side of the double bond, or are they on opposite sides of the double bond? And in this case, they're on opposite sides of the double bond. Now, you can memorize Z means same, same. So, and E will be opposite. So what that means is the molecule I have drawn is E. How do I change it to make it Z? So in order to change it to make it Z, I just have to choose a side. Let's say I'm choosing the left side, and I'm going to change the 2 groups. So instead of methyl down and hydrogen on top, I will now put hydrogen at the bottom and methyl group on top. And so in this case, both of my circle groups are on the same side of the double bond, and this would be Z. So this is the structure of Z3-methyl-2-octene.